started. My name is Kristen, and I'm serving as an AmeriCorps member with Conservation Nebraska's Common Ground program. Just a few housekeeping things before we get started. Everybody is on mute and their cameras are turned off. If you have a question you would like to have answered, you can place it in the chat box and we will answer them at the end. We also have a brief survey at the end of the webinar, so if you would be kind enough to stay and take that, we would really appreciate it. Tonight's webinar is on winter precipitation in Nebraska. We have Lindsay Johnson from the National Drought Mitigation Center. She's originally from Aurora, Colorado, and she grew up skiing, rafting, hiking, and playing soccer. She wanted to be a climatologist since she was 13 and visited the Great Barrier Reef. She completed her bachelor's in meteorology and climatology at the University of Nebraska-Lincoln in 2011. Upon completion of her bachelor's degree, she worked as an operational meteorologist at, I'm not sure how you pronounce that, in the South Pole.
Yeah.
So she went to Antarctica, which is super awesome. She got her master's degree in earth science, specializing in climatology from the University of Nebraska or the University of Northern Colorado in 2016. And between 2016 and starting her PhD in 2019 at the University of Nebraska-Lincoln, she worked as an associate scientist at the University Cooperation for Atmospheric Research. She is in her final specialization in climate assessment and impacts. Lindsay joined the National Drought Mitigation Center staff as a climatologist and U.S. Drought Monitor author in January of 2023. Her current research focuses on science and climate science communication and accessibility, as well as trend analysis of precipitation patterns. So welcome, Lindsay. Thank you.
Thank you. So I guess I will go ahead and kick it off here by sharing my screen. I'm just going to drag this over so I can actually look at everyone while I am. Come on. Sorry. It's not wanting to let me pick the right screen. Perfect. Right, can everyone see the slideshow? Yeah, hope so. Okay, so yeah, my name's Lindsay Johnson, and I am a climatologist at the National Drought Mitigation Center. A lot of what I do is just some basic regional climatology, especially in areas of drought. So obviously a lot here in the plains. But outside of that, I love snow. I've always loved snow. Growing up in Colorado, it was kind of like ingrained in me. We went skiing every weekend. So we're going to talk about how snow is important to Nebraska, but also what's going on with current snow and future projections of what winter and snow will look like. Come on. Are you not going to let me? There we go. So I kind of just went through this. We're going to go over some basic science because I don't know how much everyone knows, and I want to make sure that everyone's on a even playing field. So if I mention something, hopefully this will trigger like things you've already learned, or it will just help you understand as I go on. So first we're going to talk about the climate system. I mean, I've spent like probably over a decade studying this, so it's not a simple thing. But generally speaking, we talk about the climate system broken up into 5 interconnected spheres. We could sometimes argue 6, but right now the consensus is 5. So to start out, we have the hydrosphere, then the atmosphere, cryosphere, lithosphere, which is Earth, and then biosphere. All matter on Earth can be placed into one of these or more spheres, because if you think about like water, it doesn't just exist in the hydrosphere. Like water's in the atmosphere, water's in the cryosphere, water's in the lithosphere, water's in the biosphere. So it's there, but it's part of everything. So none of these are ever talked about in isolation. And energy moves through this system Generally, we look at it like a closed system, with the main energy point being the sun. So the sun drives like all the movement of temperature, air, water on Earth. And I'm sure we all saw this back in like middle school. Just basic hydrology. Talking about the water cycle. So basically, ideally, the motion of the water from the ground to the atmosphere and back. There can be a lot of processes that are involved in this. We're going to just go over some of the basic ones that are just good to know as we talk about like what's happening to precipitation in Nebraska. So you have evaporation, so water turning into gas as it evaporates up into the atmosphere. Evapotranspiration, so basically this is plants essentially letting off or water is transferred into water vapor through plant stomatas. I'm not exactly sure how. I'm not a biologist. I know it happens. Then you have condensation. So condensation is basically when that gas then will change into a liquid state. So when you get a cloud, that's through condensation, because particles are getting together and it's kind of making up a little bit of liquid. Precipitation, I mean, we hear it every day on the news. Basically, it's those condensed particles up in the air that basically become too heavy for it to stay up there. So it falls. What kind of precipitation we get is based off the temperature. Most rain actually starts as snow because it's so high up in the atmosphere, and then as it moves down, it gets warmer and turns into rain. And then runoff. So basically, is the precipitation being absorbed, which we'll talk about next, or is it running off? And it runs off either because the ground can't absorb moisture or is completely saturated. So like streets are not going to absorb precipitation. There's going to be runoff. Or if you are like you just had a ton of rain, everything's already soaked and saturated. No more water is going to get in there, so it's just going to run off. And that's where you can get some flash floods. Then you have infiltration, which is basically the soil soaking up precipitation. And this will depend on oftentimes the type of soil, how dry or wet it's been, things like that. So, as we know, Nebraska experiences all seasons. And they can be pretty extreme. So when we talk about these extremes, there is a classification system called the Köppen classification, climate classification, which basically tries to break down like climatological regions around the world based off of their latitude. So basically, how far north, south are they based off the equator? Then you got the amount of precipitation, and you got temperature. Generally speaking, these are kind of the three main things we think about when we think about climate. And all this is important when you talk about how things are changing. So Nebraska's climate is actually, I wouldn't call it super diverse, but there are some diverse climate types. The big one is continental. And continental basically comes from how far inward are you in a continent and how far away are you from a major body of water. Continental climates basically will have those extreme temperature variabilities, so that's why we get hot summers and cold winters. We also have, and this is because of the location, we have the arid or more arid areas of like the panhandle towards the more humid areas of the eastern Nebraska. These quick graphs are called climate graphs. I like them. They're pretty. They're fun to show. If you have time to analyze them, they're great. All these are found on the Nebraska State Climate page. Basically, these show you what the average high temperature is, average temperature, what is the high, average, and low temperature for any given month for a certain location And then the green bars are generally how much precipitation do they get. So as you can see, temperature-wise, they all kind of follow the same trend, peaking, July, like end of July into August. But the big thing you can see here is the precipitation. So you have here we have in the panhandle, I'm just doing rough, so 3 inches in May and June. It increases a little bit here, but then the further east we're moving, you're seeing it's up to 4.5 inches. So this just gives you an idea about how these different climate areas kind of vary. Not significant, but it does make a difference in, agriculture or how the land can be used. Okay, now we've gone through all the science. Why does all this matter? So going into basic climate change, I'm sure we all already know the Earth is warming. It's already warmed about 1.8 degrees Fahrenheit. And I don't know about December, but well, because obviously it's not over, but the last 13 months globally have been the hottest months ever. Hottest, January, hottest February. I know for the US, it's pretty much been the highest or the third, in the top 3, pretty much for every month. I to list the numbers of records broken this past year on temperature would be crazy. It was really hot. The big thing we are noticing is what seasons temperatures are changing, because there is a seasonality that is showing up in some of our climate observations. So here at the top, we have the annual precipitation and temperature. I just circled, not like none of you know where Nebraska is, but I like people to make it simple for me to find. So we're kind of right in that transition zone, which is also why Nebraska has that weird, arid to humid climate. So we're definitely seeing warmer temperatures, but we're not experiencing what they are here in the north or the southwest. We are seeing increases in the in precipitation. Winter, you're seeing definitely a stronger warming signal. Precip is very much more I don't want to say isolated, but it's a little more spotty than this overall increase. But summer, at least here in the plains, and as you can see for most of the Midwest and South, there's a little bit of warming, but not much. Most of that is happening west of the Rockies. Same with precipitation. I mean, west of the Rockies, it's getting drier. Central, east to the Rockies seems to be seeing a general increase in precipitation. I say that because precipitation is really hard to observe, because are we observing the number of events, the amount per event, the total amount, the average amount? So it's really hard to figure out exactly what's happening, but generally speaking, we are seeing an increase in the amount of precipitation. We are also seeing an increase in the number of frost-free days. So as you can see, from basically 1980 to 2020, the number, so this is the change in the number. So we've had a 10-day, a 10-day increase, or 10-day decrease, my bad, on the number of frost days. This can be both good and bad. It has its goods and bads. I mean, it just depends, but there are implications later for snow. We're seeing some changes in extremes, except again, the plains, especially the northern plains, we're a weird region. Because I think we got the more humid Midwest, we got the dry West, we have the hot and humid South, and it all converges and hits us. Oh yeah, and we have Canada, who loves to give us their nice cold air. So we're seeing the number of hot days, at least here, decrease. So days with over or equal to 95 degrees, we've decreased generally 4.5 days. Yay, we don't care. Cold days, though, we are seeing an increase or a decrease in the number of cold days. So that's days below freezing, so 32 degrees. That can be good or bad. Again, depends. If you hate the cold, you're probably like, yay. If you love the cold like me, you're probably like, I don't want summer yet. A big thing that is of concern is the warm nights, because that is where cooling happens for plants, for humans, and it's really needed to help things from staying too hot. Again, our region, the high plains, are just being weird, and we're not really seeing a change at all. It's like -2 or -0.2, I should say. But you can see there's not a, like the Southwest. So basically down here in the South is kind of where it's mostly changing. Frequency of precipitation, this is kind of what I got at. What do we look at? Do we look at how many heavy precipitation events do we have, or what our average is, or what the frequency is, or what the sum is? So there, as this kind of showed on the previous, there is an increase in precipitation. Again, so that's a general consensus, but it's like, how is it increasing? We're not entirely sure. So now if we look at like how climate change is already observed to be affecting Nebraska, we have, this is just annual temperature anomaly. So basically how far from normal is the temperature. So the orange dotted line is if we looked at the average temperature from 1895 to 2023. 1895 is the beginning of the meteorological record, basically. So it's our instrumental record. And then the black is the trend starting at 1980 to 2023. They're both increasing, as you can see, but definitely this shorter term average, we're seeing a greater increase. Again, same with precipitation, but if you look at these numbers, like, again, slight increase, a slight increase, but it's under 5 inches. So, and this is just annual. This isn't talking about the seasonality of how things change. Don't freak out. I'm not going to make you do math. I just wanted to put this there. So for those of you who actually like numbers like myself, you can see the equation. But essentially, this chart shows how the temperature has changed over the last 30-year average versus the first 65-year average. So basically, from the average from 1994 to 2003 minus the average from 1895 to 1960, and that's going to give us this kind of bold number of the difference. So we're seeing temperatures here of 1.4 degrees higher, 1.9 in the Panhandle. So these are broken down by what are called climate divisions. Every state has them. They don't necessarily follow it perfectly, but it's a good way to organize data. Then we go over to precipitation, which, as you can see, for most areas, like here's basically 0.5, 0.4, but you really see it here in, north central Nebraska with almost an increase in 2.5 inches a year. But warming is not uniform, as I mentioned, across the different seasons. So just so we can keep the annual maps in mind, these are those, it's not supposed to happen. So these are the same calculations that were, oh my gosh, go away, from up above, but they were broken down by seasons. Why are you doing that? I apologize. My computer doesn't like me, apparently. Let's go here. Are you gonna just stay away now? Perfect. Okay, or not. Like, yay, I used animations, boo. So basically, we are seeing a seasonality to changes. You can see that spring and winter are definitely the seasons where we're seeing the greatest warming. And if you look at winter, it's kind of like glaring. Okay, we're just gonna open this up and delete these so you all can see it better. And there we go. Perfect. Like summer is actually having the lowest amount of change, which you would think the hot days would be getting hotter, but we saw oh my gosh. But we saw earlier that that's not the case. It's already hot. We're not seeing that huge increase, but winter is when it's really starting to get warm. We're seeing those less freezing days. We're seeing less cooling days. And then in terms of precipitation, the greatest change is here in the spring. Oops, go away. You do have some changes here in the fall, but most significantly, it's here in the spring. If you notice winter precipitation here in the bottom right corner, basically it's not changing. I mean, you got 0.01, negative 0.02. So this is basically negatable. So what does that mean? Are we going to be getting more snow, less snow? How's it going to affect water? So we know that Nebraska has warmed, with the most significant warming being here in the spring and the winter. Oopsies. So this graph here is basically showing the difference in the average number of days with temperatures over freezing versus between those two time periods again. So this is basically the last 30 years and then the 30 years prior to that. And you can definitely see that there's a general trend to more days where our max temperature is going to be above freezing, which just kind of further shows that there's warming. And again, winter precipitation kind of not changing from what can be observed. And again, observations of precipitation are not the easiest thing to do. There's no distinct change, at least for Nebraska, for precipitation. But we are seeing changes in snowpack. So up here, this is from the latest national climate change assessment. I think it was number 5, which basically is showing different river valleys. And they're basically how much snowpack is decreasing per decade. And this is important because obviously in the spring, you start getting melting, and a lot of that snow melt goes into our rivers, helps us with, watering things. It gives us, our water for the cities. Ideally, it would soak in and refill the aquifer, but aquifer is being used up faster than it can be recharged. But so if we look here in the Mississippi, we're probably, I think, right about here. So it is decreasing by 5% a decade, which again may not seem like a lot, but when you realize how much water is stored up in that snowpack, it can become concerning because it's kind of like a storage center, because we don't need all of our water at once. It's good when it's like we have it in this frozen pile and it melts, so we just kind of get this like slow trickling of water that we can use. Whereas if it was all liquid at once and like, okay, in December all we got was rain, well, that's not going to help us come, March. So and then here at the bottom is going to be the average number of days with at least 1 inch of snow on the ground. So the dark gray is going to be the number of days from averaged between 1951 and 1980. And I guess I'll mention here, for those of you who don't know, everything in climatology uses 30-year averages. So it's kind of a rolling 30-year average. So that's why all these are 30 years. And so the lighter gray is the 1991 to 2020 average. So here we can see there is a noticeable difference between the number of days with 1 inches of snow. So like here we have North Platte, 10 more days with 1 inch of snow. So again, think of snow as like our reservoir. And the less we have as it warms, we're not going to have that storage for, into the spring and early summer. Okay. So yes. So earlier, and I am going to briefly talk about the Rockies, because as important as the snow that falls in Nebraska is, what happens in the Rockies is just as important. Just because, I mean, you think about the Platte River, comes out of the Rockies either through Wyoming or Colorado. And unfortunately, we're seeing decreases in snow or in snowpack in the mountains. Mountainous areas are actually warming faster than other areas, which means that either they're not getting as much snow, the snow is melting sooner and quicker, or less. I think I might have already said this. Pardon me if I have. If you have more rain versus snow, that's also going to change. It's going to decrease that reservoir amount that you hope for in the spring. Which then again, Colorado or Nebraska, along with many states to the west, all rely on the snowpack melt for water supply later in the year. So kind of going on this, are we getting less snow, more rain? Because as we saw before, we're not really getting a change in the amount of precipitation. So are we getting more rain events? Now, without going into actually doing a research study, I don't know. I do know that I did some research for the Northeast, which is obviously very different than now, or not now, but here. But they are seeing an increase in rain events in the winter. They're seeing an increase in rain on snow events. And these are really important because when you have the snow, the rain is going to be warmer than the snow. So when rain falls on the snow, it's going to cause some of that surface snow to melt, which again is going to cause earlier melting, which is not really what we want. We don't want all of our water in February and March. We need April and May. So all this being said, like, I don't know if anyone's ever gone to the Platte Basin time lapse. They're awesome. I picked like 2 different locations, so I'll just quickly talk and you can watch this, but again, these are awesome. So essentially, we don't know exactly how snow and Nebraska are going to be in the future. We do know that it's getting warmer. Without any significant change in the amount of precipitation, we can at least deduce that we're probably going to see less snow. Again, this is just, nothing is proven. This is just me using 1 + 1 = 2. So that's not necessarily a good thing because Nebraska especially relies on water reservoirs. Well, a large part of the state does use irrigation. That irrigation comes from somewhere. So it's becoming more critical. We're seeing earlier melting, which is causing issues in the summer. Like I feel like whenever I drive to Omaha, whenever I cross the Platte River, I always feel like it's insanely low. Granted, I've only lived here for like 8 years, so I haven't seen it. more than that, but it always seems like it's really low in the summer, but it like this past spring, it was really high. So these are all critical things when we're thinking about snow and its importance to Nebraska, especially as a resource, because the changing of snow into rain is going to change how and when we can use the water to the best of our ability. I hope that makes sense. I'm trying to figure out a better way to say that, but I can't think of it. Um, so most of this now could just be questions because unfortunately I am not a hydrologist, so I can't necessarily get into the intricacies of how water moves through the system and recharges and everything. But I hopefully have answered some of your questions. And let's go. Come on. Are you gonna let me go? Oops. So yeah, I'm open for questions, and I know that went by really fast. I apologize. Um, but yeah, so I guess at this point, any questions?
Okay, so it looks like we do have one question in the chat. Um, they said, is there a good website for resources with climate data sets that the public and students can view?
Yes. So a great place to start. We're just gonna go. Gotta open up a web browser here because it's like when you know the website, but you can't remember the website. So that's kind of what's happening in my brain. So we can go to Nebraska Climate Office. So this is going to have a lot of really good resources. So you can get current weather. It has a lot of data. The trends are pretty good. Of course, now it's not working. Oh, that's coming out. That's the thing I mentioned that we're working on. So we have climate summaries quarterly, and then here you can have weekly weather updates. There is a way to get like Lincoln daily data. I don't know necessarily about anywhere. If you want to go to nsco.unl.edu, that's a good resource for just basic climate information. So hprcc.unl.edu is for the High Plains Regional Climate Center. You can request any data you're after. I often just use the summary maps. They're great. You can fiddle with them. Then you have the ncei.noaa.gov. Unfortunately, like many government web pages, this one's going to be not the most user-friendly. So you can access or go to the archive data. One I really like is climate at a glance. I use this page all the time. It's amazing. If it wants to load, it sometimes takes a while, plus after the major flooding in Asheville. But basically, this will let you pull up maps of either global, you can get all the way down to county level. You can look at time series. You can look at rankings of how hot or cold it is compared to the record. So yeah, you can I like looking at, we'll launch this, we'll look at the average temperature. Again, you can have so many different things. You can display a trend. You plot that, and you can download the data. You can download the picture. Here's the data. So you can kind of do this kind of stuff. Then you can do it by region, state, division, county, and apparently now city. If we go back, this is probably my favorite thing, is you can look at the average temperature for the contiguous US for November. So here's what I was saying, like for the September through November, it was the hottest that has ever been recorded since 1895. And you can just see how that record just continues until basically last year. So these are all really good resources. You can always email me if you didn't get my email. I'm sure Kristen could probably get it for you. Because I have like here's my website for climate data and resources. There's a ton. So it just depends on what kind of information you're after. So there's that. Okay, now I see that Trey had a question about how the Earth changes temperatures naturally for its history, and it could it be changing naturally itself? So this is kind of that yes, but kind of question. So it changes naturally. It always has, it always will. The way I look at it is, and you might have heard this analogy before, but it's really one of the better ones, is so the carbon dioxide, water vapor, methane, that's all floating in our atmosphere. It kind of acts like a blanket. So as we get some of that sunshine that comes in, gets trapped under the blanket, which actually makes Earth livable, because without like our atmosphere or the greenhouse effect, it'd be like -17 all the time and life couldn't exist. So the greenhouse effect is actually a good thing. What essentially is happening is as we put more of these gases out, so carbon dioxide, methane, we're essentially just taking more blankets and we're throwing it on the Earth. So you know how if you have one blanket on you, you can trap some of your heat and some of it still gets out. Like it's not like a little oven, but the more layers you put on yourself, the less of that heat is going to be able to escape. So that's essentially kind of what that greenhouse effect is, and kind of why we can correlate human activity with increasing of carbon and methane and increasing of the greenhouse effect. So it's again kind of like 1 + 1 = 2. And we definitely take into consideration the natural variability, which would actually have us cooling right now if we took everything like the Earth cycle, my Milankovitch cycle. So its tilt, its wobble, its orbit, if we took into the sun cycles of the sun being cooler or warmer. So all these things are taken into consideration. Many of them are like hundreds of thousands of years. And if everything was basically you eliminate humans, we'd actually be on a cooling trend right now. So there's that. Another analogy I like to use is, yeah, like climate's warming. Baseball players are strong. Some baseball players choose to take steroids to get stronger. Carbon dioxide and methane are steroids. So essentially we're taking something that's already happening and we're just boosting it. I hope that makes sense. Because it's basically been a lot of deduction. Like, okay, if we take out this element and this element and this element, what do we find? And then as we start adding those one after another, the one consistent thing we're finding is increasing carbon dioxide has led to increasing temperatures. And then increased temperatures add to a lot of other climate change factors. That's why you hear the controversy, global warming versus climate change. The Earth is warming, which is a part of climate change. Because some areas, like some polar areas, are actually getting colder. Antarctica is actually getting colder. Well, it's warming, isn't it? Not everywhere. We still have winters. Cold areas still get cold. We're definitely seeing changes in the extremes, basically, that have been observed thus far. So, hope that answers your question.
Okay, I don't see any other questions. If anybody has anything, you can put it in the chat or the question box now. We are going to put up the survey, and if you would be willing to take that, that would be great. Thank you again, Lindsay, for putting this on for us. It was really informative. I learned a lot, so.
Yeah, and honestly, if I love talking climate and everything climate. So if anybody just wants to talk about climate or drought, since technically that's what I do, you can always email me. I'm more than happy to chat about all of this.
Yep, and if anybody wants Lindsay's contact information, you can get a hold of Conservation Nebraska and we can get you that information. The webinar is also recorded, so if anybody wants to watch it at a later date or knows somebody who wants to watch it, it will be put up on the Conservation Nebraska YouTube page for people to view at a later time. Okay, so let's see. I just want to make sure we didn't miss anything. Right, I think that's everything. Thank you so much, Lindsay.